God bless you, math analysis students. I'm very glad to be able to share this math analysis practice quiz with you. I know it's kind of late, but it took me a while tonight, and I trust at least some of you can benefit from it. It's so good to be with all of you this year, and I certainly want to thank God for the privilege and trust Him to lead us and guide us as we get started with this, our first quiz. So let's launch right into it. Question number 1 reads, evaluate the algebraic expression x squared minus 3 times x minus y when x is 8 and y is 2. Okay, so let's move right into this one. Wherever we see x, we're going to put 8, square that. Wherever we see x again, we put 8, and y is 2. So this one will work out to 8 squared, which is 8 times 8, not 16 now, but 64, minus, we're going to do 3, so the parentheses first, consistent with the order of operation. 8 minus 2 is 6. I think I've seen some of you who make this mistake, which I'm going to make here and then correct it. 64 take away 3 is 61 times 6. Okay, this is wrong because you don't do subtraction before you do multiplication. So you're going to do the multiplication first. So we go 64. 3 times 6 is 18. Then our answer is going to be 64 take away 18. Borrow from the 6, leave 5. 14 take away 8 is 6. 5 take away 1 is 4. So that would be our answer for that one. Okay? So beware of this, some of you, not all, but some of you. Here's another one. 2x plus 3y over x plus 1. And x is negative 1 and y is 4. So moving right into it, we go 2 times x, which is negative 2. Kind of nice to keep the negative in parentheses. Plus 3y plus 3, the y is 4. All over. X is negative 2 plus 1. Right, so working this through, get positive 2 times a negative 2 gives us a negative 4. When signs are different, when we're multiplying or dividing, then the answer is always negative. Again, when the signs are different and we're multiplying or dividing, the answer is always negative. And then now 3 times 4 is 12. Over negative 1, sorry, negative 2 plus 1, going to be negative 1. The bigger one dominates the sign. When the signs are different, then you subtract, but the bigger one dominates the final sign. Same here. Negative 4 plus 12, the bigger one is positive. So once we subtract, and we use a positive sign over negative 1. And again, when we divide positive by a negative, the result is always negative. That takes care of that one. And in this one, we're going to list all the natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers in the set. Okay, so here we go. The natural numbers will be the numbers that we count with, like 1, 2, 3, 4, and so on. We wouldn't count with negative 9. So the first one, the only number here we would count with is this one, square root of 100, which is 10. Okay, part B. The whole numbers would be all the counting numbers and 0. So we'll use 0. And then we'll also use the square root of 10, which is 10, because we would count with 10. C, integers. It's misspelled here. Integers, but it should be integers, integers, and those are positive and negative whole numbers and 0. So here they are, -9, 0, and square root of 10. Sorry, square root of 100, because that would be 10. Rational numbers. These are numbers that can be expressed as one whole number over another. Again, these are numbers that can be expressed as a fraction. So as we look here, -9 would be 1, because we can express that as -9 over 1. 4/5 is ready to go. We don't have to do anything to that one. That's already rational. 0, imagine that could be counted in it, because it's 0 over 1 would be 0. 0.25, might contend with that, but 0.25 is the same as 25 cents. It's a quarter, so 1 over 4. And then, so of course, square root of 100, which is 10, or 10 over 1. Square root of 100. So we've got a big list here. What else do we have? Irrational numbers. These are numbers that are just kind of like crazy numbers. They don't have a pattern. They don't repeat, and they're not terminating. By terminating, I mean like 0.25 or 0.75, and they don't repeat like 0.33333, which would be 1/3. That would be a rational number. So here we go. Rational numbers would be like this one, square root of 3. The square root of 3 doesn't have a pattern, a repeating pattern. It just goes all over the place. And then finally, the real numbers. Real numbers are just all of them. So I'm just going to put all integers, whole numbers, irrational numbers, rational numbers are real numbers, all of these. All right. Then we go to simplifying the algebraic expression. This one would be 6, and we're going to go by the order of operation. So we'll do the inner parentheses first. So I'm going to leave the outer parentheses. Got my 5. 5 should be here. And then do the inner parentheses first. That's P means PEMDAS. So this is understood to have a -1 here, right here. So -1 times positive 2y would give me a -2y. -1 times -4 give me a positive 4 in here. Okay. Next, I'm going to do the bigger parentheses now. Leave the -5 as is. And then in here I have 8 plus 4. That's give me 12. 12 minus 2y. And again, I saw somebody do this, make this mistake, I think, if I remember right, is this step right here. They go 6 minus 5, and I think they get 1. And then they multiply that 1 by 12 minus 2y. Please be aware of this. This is wrong. We're going to do the multiplication 5 times this first, and then we do the subtraction afterwards. So here we go. Leave the 6, and then -5 times positive 12 would give me -60. And -5 times -2y would give me a positive 10y. And now I really don't need this. I'm sorry, because I've just multiplied. So now I can do 6 take away 60. That would be a -54 and plus 10y. All right, so that takes care of that one. Number 5 would be a bit similar. Just that you have to work out the top and work out the bottom and so on. So let's see. Let's do the parentheses here up top. 5 take away 1 would be 5 take away 6 is -1. That is squared. And then we'll do the parentheses -2. Parentheses first, so 3 take away 7 is -4. And downstairs I have 89 minus, we're going to do the parentheses first. 5 squared is 25, so that's 3 times 25. Working this out, -1 squared would be a +1 because that's -1 times -1. And -2 times -4 is going to give me +8. The denominator I have 89. Take away 75. Upstairs I have -1 plus 8 would be a +7. And downstairs 89 take away 75. That would be 14. And when I reduce that, it would give me a half. On the other side, now we get to the exponents. This is getting to the P2. We have 2 to the 8th over 2 to the 3rd. And here, you could do it this way. 2 to the 8th. And since 3 is a smaller exponent, we bring it upstairs and it becomes 2 to the -3. And now since the base is repeated, we add the exponent. So this would be 2 to the 8th minus 3. We're actually subtracting like this. And this would be 2 to the 5th. This one here, the base is already repeated. 3 cubed times 3 squared. So we just simply add the exponent. 3 plus 2. So this would be 3 to the 5th. I could work these numbers out. I know you can, so I'll just leave it that way. This one is the division. So here we would do x to the 14th. And then we bring the x to the -5th upstairs becomes a positive. And now we add them. So 14 plus 6 is 20. And we go to this one. This is 3x to the 4th, y to the 6. I can hardly read this exponent, to be honest with you. But here I'd like you to see that the exponent of 3 is going to influence everything here. So you do -3 cubed times x to the 4th, that is cubed, and then y to the 6, if that's what it is, cubed. So -3 cubed, since the exponent is odd, it's going to be a negative. So this would be a negative. 3 times 3 times 3 would be 27. X to the 4th, all cubed would be multiplying these together. So this would be x to the 12th. And y to the 6th cubed, that would be y to the 6 times 3, 18th. All right. My time is almost done. So I'm just going to go ahead and make sure I do the verse with you, write a scripture which reminds you that it is impossible to do well in math or in any worthwhile endeavor. And I'm sure you can resoundingly say with me, for with God, nothing with the arm motion will be impossible. Okay, I think that's pretty much it. With this one, you just have to multiply this times this,